Okay, today we are going to be working on 2.2, solving one-step, two-step, and multi-step equations. We're going to start off with a bit of information, and then we're going to go through examples. So, when asked to solve an equation, you need to isolate the variable. Or in other words, you need to get it by itself. So for example, having x equal a number. So when asked to solve an equation, you need to isolate the variable, or in other words, to get it by itself, whereas you have x equals a number, or so forth. Now, in order to solve equations, you need to use inverse order of operations. So we'll be using our inverses to simplify and solve our equations. And at the end of the day, we have a golden rule of algebra. Which is do unto one side of the equation what you do to the other side of the equation. So the golden rule of algebra. What you do to one side, you must do to the other side of the equation. Okay. So we're going to go ahead and get started on working through problems. The instructions that you are going to follow are to solve for all the following. Simplify all fractions to simplest form leaving as improper when necessary. Solve for all the following and simplify fractions. Sorry, simplify all fractions to simplest form, leaving as improper when necessary. Okay, let's try our first problem. M plus 8 equals 14. Now, in order to solve for M, or to isolate M, we want to get rid of the plus 8. And so in order to do something to one side and do it to the other, we need to use those inverse skills to do so. And remember, when we're thinking about our inverse skills, we're thinking, what can we do that is either the opposite or reciprocal in order to create a value that cancels out. So in this case, when we're adding 8, in order to simplify, we would use the inverse property of addition, and we would subtract 8. Now, what we do to one side, we must do to another. I'm going to subtract 8 from both sides. And when you subtract 8 from positive 8, that creates a 0 value. So therefore, it's really like saying m plus 0, but we don't need to write that. So therefore, we are just left with m. On the right side, however, we want to simplify that value. So 14 minus 8 gives us a value of 6. So m equals 6 would be my answer. And the best way to make sure that you actually solved your problem correctly is to substitute the value back in. So we think the answer is 6. Well, does 6 plus 8 equal 14? Yes, it does. So therefore, this has to be the answer for number 1. Let's try number 2. -7 equals b minus 3. -7 equals b minus 3. So again, we're trying to isolate b. So we need to get rid of what is near or with the variable so that we can isolate it. And in this case, we have a subtracting 3 or a -3. So the opposite or the inverse of that would be to add 3 to both sides. And again, when you do that, that creates that 0 pair, which leaves the variable by itself. Now here we have -7 plus 3. They're opposite signs, so therefore we want to find the difference, but recognize which one it should stay as far as positive or negative. And in this case, this should be -4. Now, keep in mind, we also learned a property that allows us to rewrite this answer. So -4 equals b is great, but I could also rewrite it as b equals -4, which is typically how I and most math teachers will write their answers. Both mean the same, but in most cases, we typically always start with the variable equals and the value in which it equals. Moving on, let's try the next one. Number 3. 3x equals -9. 3x equals -9. Now remember, when you have a number and a variable or two variables next to each other, they are using multiplication. So really, when I say 3x, I mean 3 times x equals -9. And we can go about solving this in one of two ways. Now, in reference to our inverse properties that we learned the inverse property of multiplication. And so in order to use our inverse operation, we would need to find the reciprocal of 3. So the reciprocal of 3, keep in mind, is like saying this is 3 divided by 1. So the reciprocal would be 1/3. And I'm going to multiply Oop, forgot my colors. Let's try that again. So everything's still colorful. We're gonna multiply by 1/3 on both sides. Because when you multiply by the reciprocal on both sides, this creates a value of 1. Now we like the value of 1, but do I actually need to write 1x or 1 times x? No, I can just leave this as x. So really it's unnecessary and unwanted to write it as 1x because we know when a variable is by itself, that 1 is always there. Now let's look at the right side, however. What do we get here? Well, again, keep in mind that any number without a denominator is really a denominator divided by 1. And we want to think about, in this case, about cross-simplifying. Right? Cross-simplifying means from left to right, diagonally, we can look at simplifying, meaning dividing those numbers with each other. So obviously 1 and 1, there's nothing I can simplify. But with -9 and 3, I can simplify because they both have factors of 3. 3 can divide by 3, and we get a value of 1. -9 can divide by 3, and we get -3. By doing this, we simplify our numbers before we need to multiply across. So I get -3 times 1, which is -3, and 1 times 1, which again, we wouldn't need to write because we don't need to write divided by 1. So we get a value of -3. So this is one way of solving this problem. Another method you could use to solve this problem will look like this. So when we learned our inverse properties, we talked about the inverse property of multiplication. We can, in fact, use our inverses in reference to division as well. Because we have 3x, which is 3 times x, I can do the opposite of that, which would be by dividing by 3, because multiplying and dividing work together. So instead of multiplying by the reciprocal, I could instead just divide by the number, because since I'm multiplying 3 times x, I can divide by the number as well. And we'll have a similar process. 3 divided by 3 creates a value of 1, therefore leaving x by itself. And over here, it would just be a different type of math. As you can tell, we used those numbers before, it just looks a little differently. -9 divided by 3 would still also equal -3. So as you can see, you get the same answer regardless. It's just a different process. Either of these are acceptable and either of these would be allowed on a test. Just depends on your preference. I'm going to go ahead and switch my papers to the next problem. Number 4. In this case, we have y divided by 4 equals -3. Y divided by 4 equals -3. So in this case, currently we are already dividing by 4. And so the opposite of dividing, like we talked about in the last one, would be multiplying. So the easiest way to solve this would be to multiply both sides by 4, because we're already dividing by 4. The inverse would be to multiply by 4. And the reason being, again, is that when I look to simplify, 4 divided by 4 creates that 1 value, which is what we're searching for. We want just there to be one variable left. And on the right side, we get -3 times 4, which is -12. Now, so far we've worked with some simpler numbers. Let's see what happens when we have a fraction that's incorporated in here. For example, k divided by 6 equals -3/2. K divided by 6 equals -3/2. So much like the last one, in order to get the variable by itself, we want to get rid of that denominator. And because we're dividing by 6, we now want to multiply by 6. I'm going to multiply both sides by 6. On the left side, that creates that 1 value. And we're left with k by itself. On the right side, we want to work with our cross simplifying. So remembering that any number can be divisible by 1, we want to look at what we can simplify so that our numbers are smaller before we have to multiply. So when we look at that, -3 and 1, nothing's going to simplify. However, 2 and 6 can simplify. So 6 and 2 easily divide, and 6 divided by 2 is 3, and 2 divided by 2 is 1. Therefore, when we multiply across, -3 times 3 is -9, and 1 times 1 is 1, but we don't need to write a denominator of 1. So we're left with k equals -9. I'm going to go ahead and write the next one, and I want you to try it on your own, which does mean you need to pause this video, try the problem, and then come back to see if you got it correct. M divided by 4 equals 5/2. M divided by 4 equals 5/2. Let's see how you did. So for the simplifying of this one, we're going to multiply both sides by 4. On the left side, that creates that 1 value, which leaves us with m by itself. On the right side, we want to consider what we can simplify. So 5 and 1 can't simplify, but 4 and 2 can simplify. 4 divides by 2 as 2, and 2 divided by 2 is 1. Therefore, when I multiply across, I get 5 times 2, which is 10, and 1 times 1, which is 1. And we get a nice answer of 10. Go ahead and take some time to correct your work as needed. Using fractions in a different way, we're going to try number 7, which says 7c equals -7/2, or -7 divided by 2. Now, in this scenario, much like our problem from number 3, we have a number multiplied to a variable. So the answer could be to multiply by the reciprocal or to divide by the number itself. Now, in the cases like this, we would not divide, because what would happen is that we would want to divide by 7, but then we're going to have to divide a fraction by another number. And this would never be a situation that we want, right? So therefore, we do not divide with fractions, much like we had learned before. So in this case specifically, we would multiply by the reciprocal instead. So therefore, if I solve a problem like this again, I know that I cannot divide because on the right side, I already have a fraction. So the only way to solve this would be to multiply by the reciprocal, which in this case would be 1/7. When we look at that, 7 divided by 7 creates that one value. So we do get the C by itself. And on the right side, when we look at our numbers, 1 and 2 can't simplify, but -7 and 7 can. I can divide both by 7. -1 times 1 is -1. And for the first time, we have 2 times 1, which is 2. So if you ever get a number other than 1, you do in fact need to write that. Everything so far has just been ones on the bottom. But in this case, we still had a number 2 times 1. Therefore, my answer ends up remaining as -1/2. So again, the lesson learned here is that we do not divide with fractions. We always multiply by the reciprocal. I'm going to go ahead and let you try number 8 to see if you've learned your skill from number 7. 4/5 m equals 28. 4/5 m equals 28. Keep in mind the skill we learned on number 7. So in this situation, you could consider only one thing, which is to multiply by the reciprocal, because we do not divide with fractions as stated above. So the reciprocal of 4/5 is going to be 5/4. And we're going to multiply that to both sides. Four divided by 4 and 5 divided by 5 create that one value. So 1m, which again is always our goal, to get the variable by itself. Now over here we have some rather large numbers, but that's where cross simplifying comes into play. 5 and 1 can't simplify, but 28 and 4 can. Two things that let me know that. One, they're both even, so I know they're at least divisible by 2. But hopefully you notice that 28 is also divisible by 4. So therefore 28 divided by 4 is 7, and 4 divided by 4 is 1, leading us to get an answer of 7 times 5, which is 35, 1 times 1, which is not needed, and our final answer. Now, there may be a case where you come across where you have numbers that don't simplify, and that's okay. Just like anything else, you would leave the numbers as improper fractions that are simplified if it does not simplify to anything nicely. From here, we're going to go ahead and switch over to our two-step skills. Now that we've mastered our one-step skills. Okay. Now, when we have two-step equations, that means we're gonna obviously have to do more than one step, but what matters is the order in which you do those steps, okay? And so you need to use your inverse order of operations working with anything with the variable. You need to use your inverse operations with anything working with the variable. So as we look at our first problem, -1 equals 2 plus 4a. As you can see, we have two different things affecting our variable or working with our variable. We have a 2 and we have the 4. Now we have to think about what operations are happening here. The 2 is being added and the 4 is being multiplied to the variable. So in order to solve this, you have to kind of work outwards, inwards. So you need to work with what is not attached to the variable, but on the same side as the variable. So in that case, that would be the 2. The 2 is not attached to the a, but it's on the same side as the a. So that's the first thing we want to get rid of. And we're going to subtract 2 to both sides. And remember, our goal, whatever we do, is to eliminate that issue. So now we have -3 equals 4a. Now that we've moved the 2 by subtracting it, we're left with just the 4a. And in this case, since 4 is multiplied to a, I'm going to divide by 4 to both sides to isolate the variable even further. And I'm left with a on the right side. And on the left side, I get -3/4. Now that doesn't simplify. So therefore, I'm going to keep my answer as just -3/4. And as we stated before, in most cases, the proper way to write an answer is with the variable first. So therefore, I'm just going to simply rewrite it as a equals -3/4. So again, with two-step equations, you have to work your inverse operations, working with anything on the variable side. So the 2 was furthest away from the a, so I subtracted it. And then the 4 is right with the a, and therefore I divided it. Let's look at the next problem. 26 equals 3m plus 5. Go ahead and try this problem to see what you get. So, looking at this problem, what we look for is what side is the variable on, and what is with the variable but not personally attached to it, which would be this plus 5. So in this case, I'm going to subtract the 5. Which gets 26 minus 5 as 21, equaling 3m. And then we're left with 3 times m. So I'm going to divide by 3. And 21 divided by 3 is 7. And m by itself, which leaves me to m equals 7. I hope that one went well. And again, as a reminder, we work with what is with the variable, but not attached to the variable first. And then we work with what is attached to the variable. Now, because I know we love our fractions, let's try and work with a fraction problem. Negative 5x minus 2 equals 1/2. Negative 5x minus 2 equals 1/2. So looking at what we need to get rid of or move, we first need to add the 2 to the other side. Now, in this case, when I add the 2, I can't actually add 2 to 1/2 as is. So we're going to, over here to the side, do a little side pocket, and we're going to add those together. 1/2 plus 2. Now remember, the skill that you were taught is that you have to have a common denominator. So currently you have a denominator of 1 and a denominator of 2. So in order to correct that, I would need to create a common denominator. So I'm going to multiply by 2 over 2, which would get me 1/2 plus 4/2, which now has a common denominator, which simplifies as 5/2. So 1/2 plus 2 will give me 5/2, which I'm just going to go back and put in the problem. Okay, and this skill hopefully is much quicker for you and now that we've practiced so many fractions. But if not, this is our skills that we need to follow. From here, we now get an example of something we've seen before, where we have a number times a variable, but it is equal to a fraction. So therefore, the only thing that I would be able to do is to multiply with the reciprocal. Now the reciprocal of 5 is just going to be 1/5. But in this case, we're going to multiply by the 1/5. So 5 and negative 5 simplify. However, this would still leave me with -1. And on the other side, 5 divided by 5 would also just be 1. But what happened here is that since we had a negative, I actually end up with -x equals 1/2. Now, my variable is by itself, kind of, but I have a negative out here. And what does that actually look like? Well, in fact, it's like we have a -1x, right? Our goal is just to have positive x, or positive 1x. So when you have this situation with a negative variable, we are not done. Okay? You can't leave a negative variable. So in this case, we will want to simplify by dividing out the -1 or multiplying by -1. Dividing by -1 or multiplying by -1 do the same thing. So a negative times a negative is a positive, which gives me back my positive variable. And in this case, I end with -1/2 as my answer. So a couple skills learned in that one. That was a little bit of a tougher one. Okay. So first thing we had to think about was creating common denominator. And then we had to worry about a negative variable. Let's try the next problem. Next problem we have 2 divided by x equals 5. Okay, 2 divided by x equals 5. Now, in this case, the first case we've seen this, we have a variable in the denominator, okay? Another situation where we can't simplify as is and we can't leave it as is, okay? So therefore, the rule that we want to think about is that you cannot or you can't solve for a variable in the denominator. You can't solve for a variable in the denominator. Now, the next question you might ask is, well, how do I get rid of a denominator or variable in the denominator? Much like we got rid of numbers in the denominator, because we're dividing by x, the only way to get the variable out would be to do the opposite, which would be to multiply both sides by x. Now, it seems a little silly, but x divided by x does in fact cancel out, and it leaves us with just 2. And that now moves the variable to the other side where we get 5x. Now that x is in the numerator, I can simplify as normal, which would be to divide by 5 leaving us with 2/5 equals x, or in other words, x equals 2/5. So the major rule we learned here is that we cannot solve for a variable in the denominator. So in order to get it out of the denominator, we multiply it to the other side, which then we can divide. Number 13, x minus 8 divided by 3, all divided by 3. X minus 8, all divided by 3 equals 7. Now this one looks a little weird because we do have two operations. However, they both seem to be affecting the variable. But if you consider it, what is closest to the variable in this scenario? Well, technically the minus 8 is what's personally attached to the x. And the divided by 3 works with both numbers. So I want to move the divided by 3 and use my inverse operations to get it to the other side, which anytime we have a denominator, that means we're going to multiply that number to the opposite side. So therefore we can create that one value. Well, in this case, we're still going to be left with everything in the numerator, but I cannot access the x or the -8 unless that 3 has been removed. And then we have 7 times 3, which is 21. From here, now that the 3 has been removed, I can effectively now change and get to add 8 to both sides, leaving us with x equals 29. Now we're going to start looking at multi-step. Okay, and there's going to be a couple different versions of multi-step that we look at. And so we'll break them apart from here. The first type of multi-step equations we're going to look at is combining like terms. Which we already talked about when we referenced distributive property. But to remember, combining like terms means that if both terms have the same variable, they can be combined together. Or if you have two constants where they're a number without variables, those also can be combined together. So number 14, we have 5 equals 5m minus 23 plus 2m. Before I can simplify using my two-step process, I need to combine like terms. So looking at this, we have two different terms with a variable of m, meaning I can combine them. These are like terms. And so 7m plus 2m would give us 7m. I don't know if I said that right. 5m plus 2m equals 7m. I apologize. Can't remember what I just said. Now that we've done that first process, we can simplify using our two-step process. So from here, go ahead and solve the remainder of this problem. Hopefully, the next step you worked with was adding 23 to both sides. Which is 28 equals 7m. From here, we would divide by 7. Which would leave me with 4 equals m. Or in other words, m equals 4. So once you've combined like terms, everything else is just like all the other two-step problems we have been working to accomplish. Let's try one more of those to see how you do. And when I say let's you try. Number 15. 11m minus 8 minus 6m equals 24 minus 2. Go ahead and try number 15 and reference number 14 to help you along. Let's see how you did. So, as we can see, these are like terms. So 11m minus 6m would give us 5m minus 8. And 24 and negative 2 are also like terms. They're both numbers without variables. So simplified would give us 22. From here, we would add 8 to both sides. Then we would divide by 5. Leaving us with m equals 6. Hopefully you were able to get 6 and that worked out just nicely for you. The next type of problem we're going to work with is distributive property. Now we've worked with distributive property before, and so this will be very similar to that. Negative 8 times the quantity, or parentheses, 2x minus 1, parenthesis, equals 36. So there's two ways of going about this. With distributive property, you were taught to distribute this number to both or anything inside the parentheses. But you also have to keep in mind that negative 8 times this could work an advantage of being able to simplify differently. Now, in this case, I couldn't simplify by dividing by negative 8 to both sides because 36 isn't divisible by negative 8. So the only way to solve this would be, in fact, to distribute the negative 8, which gives us negative 16x plus 8, a negative times a negative, which equals 36. From here, I'm going to subtract 8 to both sides. Which equals 28. And then I'm going to divide by negative 16. Since 28 and 16 don't simplify nicely, we have to consider what they do simplify it. Well, they both divisible by 2. They're also both divisible by 4. So if we simplify both by 4, we get negative 7/4, which would be my simplified improper answer. Now, what I said earlier would work for this one. 7 times the quantity of negative 3k plus 2, parenthesis, equals 21. In this case, rather than distributing the 7 and making my numbers bigger, I want to consider the fact that I could divide by 7 on both sides. Because the fact that 7 divides nicely into 21, this plan will make my numbers smaller, therefore easier to work with going forward. But like I said earlier, I couldn't have done this up here because 36 does not divide by 8 nicely. We would have dealt with a fraction, which would have made things a lot harder. So rule of thumb, if this number does not simplify within the other number evenly, you want to use the distributive property as is. But if the number multiplied to the quantity does divide easily and nicely, therefore we want to make our lives a little bit easier. Which gives us negative 3k plus 2 equals 3, which is a lot easier and nicer than dealing with the bigger numbers. Go ahead from here and solve your problem. From here, we're going to subtract 2 from both sides. And then we're going to divide by negative 3. Leaving us with k equals negative 1/3. Now, technically we had 1 divided by negative 3, but in math, we always pull the negative up to the top to leave it as negative 1/3. And our last example, which of course means I have to do one more page, is number 18. 6 equals 5 minus d, all divided by 2. Outside of that, plus 13. So this one is a multi-step on multi-step problem. And it does not deal with distributive property, okay? This is a different, just multi-step in general. Now, the rule that I've always said is that you need to remove what is on the same side of the variable, but not personally affecting the variable. So we want to go from the outest point to the inner point. So the furthest thing away from the D is the 13. So the first thing you would have to do is subtract the 13. So 6 minus 13 gives us negative 7. From here, the next thing we would consider the furthest away from D is divided by 2. So therefore, we're going to multiply by 2. Which gives us negative 14 equals 5 minus D. As you can tell, we're getting closer and closer to isolating it. From here, we have a 5. Now this is a positive 5, so therefore I'm going to subtract 5 to both sides. And I'm left with negative 19 equals negative D. Now, as stated before, we can never leave a negative variable. So I could either say I'm multiplying by negative 1 to both sides, or I can say I'm dividing by negative 1 to both sides. It'll mean the same thing in the end. So a negative times a negative is a positive, which means I would have 19 equals D, or in other words, D equals 19. That is the end of your notes. I hope that went well. If you have any questions, please communicate with your teacher to ask additional questions.